Okay, Year 12, so I'm going to finish off this question for you in your notes. So last lesson we got up to this one here, example 5, solving equations with higher powers, and we got up to this equation here, 8 cos 2 theta minus 16 cos theta plus 11 equals 0, and this was the bit where you had to re-jog your memory. The cos 2 theta, we had to use our double angle formulas. So the best one is this one over here. Cos 2 theta equals 2 cos squared theta minus 1. Because you can see I've already got, let me just change highlighter colors. You've got another cos theta in there. So if you get something all in terms of cos theta, then you can solve for cos theta or theta. But we're really just interested in cos theta this time. So let's change the rest of it. So it'll be minus 16 cos theta plus 11 equals 0. I'm just going to expand this first one. So 16 cos squared theta minus 8 minus 16 cos theta plus 11 equals 0. And collect the numbers together. So I think we should get, because you get minus 8 plus 11, so we should get 16 cos squared theta minus 16 cos theta plus 3 equals 0. Now you can factorize however way you want it, but I see cross method here being fairly easy to use. So we'll have 4 cos theta minus 1. We're going to get 4 cos theta minus 3, because that's going to multiply to give me 3 and add to give me minus 16 cos theta. So if those two multiply together equals 0, that means this, right, has to equal 0. Sorry, that was a terrible curly bracket. Let me do that again. That has to equal to 0. And then this also has to equal to 0. So we're going to get two sets of solutions. So here we're going to get cos theta equals 1/4. And on this side we're going to get cos theta equals 3/4. Okay, so we've got cos theta. If we go back to the top, have a look, what are we aiming to get? We're trying to find z, aren't we? When it says solve this equation here, it means find the pronumeral, and our pronumeral is z. But z is a complex number, right? So when we want to get a complex number, we need to have cos theta plus I sine theta. So we've got the cos theta component, but we still need the sine theta component. So we somehow have to rearrange this and get sine theta. So when I see this, though, the first thing that comes to mind for me is I think of right-angled triangles. So you could do a right-angled triangle for 1/4 and a right-angled triangle for 3/4 and just do adjacent over hypotenuse and get those, or you can use identities as well. You could use your Pythagorean identity, and that can help you find sine theta as well. So I might show you, let's see, I might do it with the triangles for you. I think I'll show you the other way later. So if cos theta equals 1/4, if you draw up your right angle triangle, adjacent is 1, hypotenuse is 4, so this side's going to have to be root 15. Therefore sine theta has to do opposite of hypotenuse, which is root 15 on 4. And then the other one, if cos theta equals 3/4, draw up your right angled triangle, and we get adjacent is 3, hypotenuse is 4, so just do Pythagoras' theorem, that last side has to be root 7. Therefore sine theta has to be root 7 on 4, opposite over hypotenuse. But this is where you have to be a little bit careful, and because your equation was originally a quartic, you had z to the power 4, there are going to be 4 solutions. So let me just write that down for you. But there are 4 solutions to an equation of power 4. Okay, so therefore our roots are z is equal to, that's your cos theta plus I sine theta. Let me write it out here. Z equals cos theta plus I sine theta. So it's just taking that format. So we're going to put it all in now. So we've got 1/4. It's going to be plus and minus because we have to have 4 roots, so you can have the negative as well. And then you've got I sine theta, but our sine theta that goes with 1/4 is root 15 on 4. So plus root 15 on 4i. You can put I first, doesn't matter. And our other one is z is equal to 3/4 plus or minus root 7 on 4. Okay, all good. So they're your 4 different roots for this equation. Okay, because they're roots because you found the solutions that'll give that equation to equal 0.